Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework. The first couple problems, is it both problems? Yeah, first couple problems are going to have to do with yesterday's lesson about finding association between categorical data. And I'll tell you, it's a little bit complicated, no question about it. This is something that's being introduced to you for the very first time, so I don't expect you're going to have this mastered. And so if you were completely confused, and even the homework can help you with this, you can just watch what I do here. So it says an unusually severe increase in gasoline prices may have motivated full-size trucks to purchase, no, truck buyers to purchase a highly fuel-efficient vehicle. Purchase behavior was collected in one area for 1 year and reported below. Okay, so here are our categories. Low fuel prices. So something happened a number of years ago where the price of oil skyrocketed over like a few months. So people who were used to paying below $2 per gallon for gas, all of a sudden were having to pay $4.50 per gas. And you know, when you're used to spending a certain amount of money on gasoline every single week, that's a significant increase. And so it was affecting people's budgets. So this time period might be a fuel, let me just make up a random number. So when gas was like $1.95 per gallon versus when it shot up to like $4.50 per gallon. Okay, so this would be the high fuel price. This would be the low fuel price era. Okay, so what they're doing is they're looking to see how many um, highly fuel efficient trucks were purchased. So these would be like your hybrids. Or I doubt that there are any electric trucks, the kind like Tesla kind of trucks. That's the idea for the highly fuel efficient trucks purchased. And then these would just be your normal trucks, the kind that most people drive on a regular basis and that have been available using regular gasoline for years. Okay, so you can see a lot of people are still buying the regular trucks. Really, there aren't that many hybrids out there. And at the same time, hybrids tend to be more expensive than just the ones that use normal gasoline. Okay, so here's the statistics. During this time period, before the gas prices went up, 37,321 people bought trucks in the area where study was taking place. 392 of those were hybrid or highly fuel efficient trucks. And the rest of them, 36,929, were just normal trucks. Then in the time period like 6 to 8 months later, when the fuel prices skyrocketed, they checked again, and there were 42,697 trucks purchased during this time period, and only 444 or 42 of them were the highly fuel efficient trucks, whereas the rest of them would be the normal. So the first question is complete the row of totals. So that's what these numbers are here for the columns. Oh, they did say the row columns too. So if I didn't add these guys up, this part doesn't really matter. The row columns, stop. The row columns really doesn't make any difference for what we are doing. This will be enough to have the column totals. And it says, what is the independent variable? And that would be the fuel prices, because we're trying to see the fuel prices affect the purchasing habits of truck owners, right? So that would be so the cars that they purchased, or whether they bought a hybrid or a normal, would be the dependent variable. And whatever is pushing that is the independent variable, which would be the fuel prices. So it says create a relative frequency table. So we're going to change these so that instead of being raw data, we're going to take 392 out of 37,321. So let me grab my calculator, and we're going to convert this to a percent. So what percent of the vehicles that were purchased, or of the trucks that were purchased, were like hybrid or electric, and what percent were normal? So I'm going to take 392 and divide it by the total, 37,321, and that'll give me a decimal number. Wait, what? Who, where, why? Is that right? Did I get that? Oh, I put 92. My bad. Hold on. Clear that out. 392 divided by 37,321 gives you, move the decimal two places to the right, and that's about 1%. So I rounded it up to 1%, which means that 99% of the people who bought trucks during the low price period still purchased the regular trucks. Okay? And that's what we would expect, right? No reason to go hybrid or electric when the prices are low. But now let's check. Did we see a market increase in the percentage of people purchasing the electric or hybrids here? So let's take 442 and divide it by the total number of trucks purchased, which is 42,697. And that's also 1%. So I guess my hypothesis would have been more people would have wanted to buy the fuel efficient vehicles during high price time periods because you would save money on gas, right? If these guys only get like 12, 15 miles to the gallon, but these guys get 25 to 30, you'd save a lot of money in gas and not have to pay on a weekly basis. But according to this, there does not appear to be any change in the purchasing behavior from the low price period to the high price period. So yeah, the high and the low prices didn't affect the purchase of fuel efficient vehicles. The percent stayed the same. Here's another one. Researchers have determined that teenagers' memories are negatively affected by getting less than 10 hours of sleep. Being good scientists, math students at North Middle School were skeptical, so they did their own study. They asked 300 students to memorize 10 objects. The next day, each student was asked how much sleep he or she got, and then was asked to list those 10 items. And the results are down below here. So the students who got less than 7 hours of sleep, only 6 of them out of the 155 that got that amount of sleep remember the 10 items. Students that got between 7 and 9 hours, only 11 of them out of the 120 could remember all 10 items. And then the third group would be the students that got at least 10 hours of sleep. Only 5 of them remember all 10 items, but there were only 25 people that fit into that category. So if we create a relative frequency table, you will see that if we take the number of yes here out of the total, 6 divided by 155 gives you this decimal number, which when you move the decimal 2 places to the right, rounds up to about 3.9%. So 3.9% of the kids who got less than 7 hours of sleep remembered all 10 items the next day. Of the students that got 7 to 9 hours, 11 out of 120 is about 9%, right? You do the division, move the decimal 2 places to the right. I rounded it to the nearest 10th place, 9.2. So that's better than the 3.9, right? But take a look at this category here. 5 out of the 25 students. Now that is a small sample, but you know, if not that many students got 10 hours or more of sleep, then you can take what you can get, and that is 25 total. So 5 out of 25 is 0.2, which is 20%. That is telling me something. The researcher said that teenagers' memories are negatively affected by getting less than 10 hours of sleep, which implies that they would be positively affected by getting more than 10 hours of sleep. And so do you see a difference? There's a clear difference there. It goes from almost 4% to 9% to 20% of the students that got 10 hours at least of sleep remembered the items. So there is a positive association to this, and as the numbers of hours increase, higher percent of the items are remembered. All right, Ruthie did a survey among her classmates comparing the time spent playing video games to the time spent studying. The scatter plot here shows the results. Okay, so you got an outlier right there, right? This person it is not following the trend, but everything else follows a downward trend. So it appears as if the more time you spend playing video games, the less number of minutes per day you spend studying, which makes sense because if you're doing this, you can't be doing that. So that's a negative association, and I wouldn't say it's a strong association, but I wouldn't say it's weak either. So moderate seems to be the best way to go. So use an ordered pair to identify any outliers. That's absolutely an outlier, and I would say that, where are we here? No, let's use this guy right there. That X appears to be about 100 and X appears to be about 140, right? You're counting by 20s there. So that one person spent a lot of time studying, but also spent a fair amount of time playing video games. I'm not sure what else they're doing with their time, but it looks like they've got two main activities in their life, studying and playing video games, whereas everybody else, you know, they're negatively affected by the playing of video games. All right, what do we have here? Sal can text 1,500 words per hour. He needs to text a message with 85 words, and he only has 5 minutes between classes to complete the text. Can he do it? Can he do this in 5 minutes? So what I did was I decided, let's figure out what his unit rate is. So if it's 1,500 words in an hour, that's 60 minutes. And to find the unit rate, you would take 1,500 divided by 60. There's your 25. So X over 1 means that's 25 words per minute. So if you take and you multiply 25 words per minute times 5 minutes, oops, that's not what I wanted to do. I wanted to highlight that. Then 5 times 25 is 125. So he absolutely should be able to do it, right? Because he only needs to do 85, and if he really dedicates the entire 5 minutes to texting, he should be able to text 125 words. And the main question I now want to ask is, who needs to text a message with 85 words? When does that ever happen? That's weird, but whatever. All in the name of math. Okay, where would the point 11, negative 18 be after each transformation described below? So the first one is a set of double reflections. The first reflection reflects over the x-axis. And remember, whenever you reflect over the x-axis, you're going to keep x the same, but it's the y value that changes to its opposite. So this is going to become 1118. Then it's going to reflect over the y-axis. And so when you reflect over the y-axis, you change the x value to its opposite, but the y value changes the same. So here, that's reflecting over the y-axis, so the y stays the same, but the x changes to its opposite. So after going through this sequence of reflections, you've had the x change to its opposite and the y changes to its opposite. So the x becomes negative 11 and the y becomes positive 18. And then it says translate 11, negative 18, 5 units to the right and 3 units down. So that's where 5 units to the right means it increases by 5 on the x line. So the 11 is going to become 16. And down 3 units means it increases by 3 on the y-axis, the y line. So 18 or negative 18 becomes negative 21. So this would be the new point. Starting with this one, goes to here after this particular translation. All right, and then checkpoint 7. At this point in 8th grade, your high school teachers are expecting you to understand how to use fraction busters. If you've been practicing along the way, you shouldn't have any trouble with this at all. Look at your denominators and determine what would be your common denominator and use that as your fraction buster to multiply times every term on the left and every term on the right of the equation, and then you'll rewrite this equation as a much easier equation to solve. So let's give this a shot here. Let me take this one and multiply everything times 15, but I'm going to show it as 3 times 5. So multiply that guy times 3 times 5, this one times 3 times 5, and I'm just going to go ahead and multiply this one times 15 because I don't have to worry about canceling out any denominators. So the 5 cancels out with the 5, leaving me with 3 times 1 times x, which is 3x. Here the 3 cancels out with the 3, leaving me with 5 times 1 times x, so that becomes 5x. And this one just becomes 30 because there's no denominator to cancel anything out. So that becomes 8x is equal to 30, which means we divide each side by 8, and x is going to be 30 over 8, which simplifies down to 15 over 4, which can be rewritten as 3 3/4. So Fraction Busters applies here. This is an interesting one. You technically, Fraction Busters is kind of when we do this. Well, no, we don't do that last part. Fraction Busters is when we do this. You take 7 times x plus 2 should be equal to 3 times x over 9, right? So watch what happens here. Let me get rid of this. We talked about this, I think, a little bit last year, but maybe we didn't. Or maybe it was earlier this school year. If our fraction buster is 21, we'll multiply each side times 7 times 3. So this side, the 3 cancels out, which leaves you with 7 times x plus 2, which becomes 7x plus 14. And this side, the 7 cancels out, which leaves you with 3 times x minus 2, which becomes 3x minus 6. Remember, send in the dive bombers. Make sure that 7 gets multiplied times each term and the 3 gets multiplied times each term. Now we can take away 3 x's from each side and take away 14 from each side, and that's how you're going to eventually get x is equal to -5. This one is a linear system. Remember, if y is equal to this, stop it. If y is equal to this and y is equal to that, then this has to be equal to that. So we set it up as 2/3 x plus 8 is equal to 1/2 x plus 10. And now you multiply everything times 6. So this times 3 times 2, this times 6, because there's no denominator to cancel anything out, this one times 3 times 2, and this one times 6. So let's do this. Cancel out the 3, that becomes 4x. Nothing cancels, that becomes 48. Cancel out the 2, that becomes 3x. And nothing cancels here, that becomes 60. I'm going to subtract an x from each side. I'm going to subtract the 48 from each side. And that means x has to be equal to 12 for this system. Now, if you chose to write it this way instead, it's totally fine, because the ordered pair on the graph would be the intersection point of these two lines. So x is going to be the first number in the ordered pair, y will be the second one. And how do we figure out what y is equal to? Well, plug in x here. Half of 12 is 6, and 6 plus 10 is 16. 2/3 of 12 is 4, and 4 plus, no, it's not. 2/3 of 12 is 8. 1/3 is 4. So 2/3 would be 8, and 8 plus 8 is 16. So you could write your answer this way, or you could write it this way. And this guy, you know, it's just a matter of multiplying everything here times 100. So that becomes 100x plus 15x equals 200. So 115x's is equal to 200. And now you take 200 divided by 115, and what do you get? 1.73, 1.74, 1.74. All right, so Lauro is going to spend a lot of time with fraction busters. It's going to be expected that you know how to do that. So anytime this pops up in your homework, please solve these problems. Show the Del Oro teachers that you're ready to move on to the next math and don't have to be retaught this over and over again until you master it. All right, I think that is it. We are done with our homework, and we are going to start getting into review mode for our Chapter 7 test. Take care. Bye.
Hey, feeling good, like I should. When